Good morning, children. Welcome to the second session. In our first session, we have discussed the importance of physics in our daily life, and I have explained why we have to study physics. Today, we will see which are the different branches of physics. Now, physics is broadly classified into two groups: classical physics and modern physics. Now we will see what is the difference between this classical physics and modern physics. Okay. Now, classical physics means all the experiments, all the discoveries, all the theoretical concepts, what the scientists were following up to the end of 19th century. That is termed as classical physics. Okay. Then, modern physics means all the discoveries, all the experiments, what the scientists have been following from the beginning of the 20th century till date, that is known as modern physics. In simple words, classical physics is the old physics up to 19th century, and modern physics is the latest physics, the new physics, which we are following now from the beginning of 20th century. Now, we will see which are the branches of classical physics and modern physics. Classical physics has got 5 major branches: mechanics, acoustics, optics, thermodynamics, and electromagnetism. Okay. Now, mechanics we have studied in class 9. Motion of an object in a straight line, then force and Newton's laws of motion, then work, energy, power, all that come under classical physics under the branch mechanics. Okay. Then comes acoustics. Acoustics, of course, means it is a branch of physics where we deal with sound and the characteristics of sound. And again, in class 9, we have studied a lesson, sound. Transverse waves, longitudinal waves, amplitude, frequency, and so many other features of sound waves we have studied. Okay. Then optics, the branch of physics which deals with light and its properties. In class 10, we have studied light, the different phenomena in light, reflection, refraction, dispersion. All those things we have studied in class 10. Then thermodynamics, we have not come across in lower classes. It is a branch of physics which deal with heat and the movement of the particles under temperature and all, which you will be learning in class 11. Now, electromagnetism. Again, you have studied in class 10 electricity, magnetism, and the properties of magnetic effect of electricity. Okay. Then, modern physics, it has got 2 branches: atomic physics and nuclear physics. Atomic physics and nuclear physics you will be studying in class 12 physics, and quantum physics you will study in detail in your university classes if you are pursuing physics as your major subject. Now, as I have told you, class 11th is continuation of class 9th physics. So we will be focusing on mechanics in class 11th. Mechanics, that is again divided into 2, statics and dynamics. Statics, it is a study of particles in rest. Dynamics is a study of particles in motion. Again, dynamics is classified into 2 groups, kinematics and kinetics. Now we will see what are the differences between kinematics and kinetics. To understand the difference, we should rewind our class 9th syllabus. If you remember, in our first lesson, that is the lesson where we have discussed about the motion of an object, we have discussed about the distance, displacement, speed and velocity, acceleration, and we have plotted many graphs with speed and time, velocity and time, acceleration and time, all such things. In this lesson, if you observe, we have never told about force. We were not bothered about the cause of motion. why the object is moving. Why is it moving under uniform motion, or why is it following non-uniform motion? We have never thought of the reason about the motion of the object. Okay, this branch of dynamics, where we study about the motion of bodies without reference of the cause of the motion, is kinematics. Whereas, if you check the second lesson, force and Newton's laws of motion, we have discussed about the force. We have discussed about the motion of a body under a particular force. So, the branch of dynamics where we study the motion of bodies under the force which causes the motion, that is known as kinetics. In simple words, in kinematics, force has no significance. We will be just describing the motion of the object. Whereas in kinetics, we will be discussing the cause of the motion, that is, we will be discussing about the force which causes the motion of the object. Here I have listed out the similarities and differences between kinetics and kinematics. As I have told, both of them are branches of classical physics, especially the branch of mechanics. Okay, and both of them describe the motion of the objects in different spaces and domains. So they are similar in certain aspects. Now the differences are, first difference is kinematics doesn't take into account the cause of motion. Okay, and it calculates only the velocities and accelerations, whereas kinetics takes into account all the causes of motion, including forces and torque. Torque again you will come across in class 7 in rotational motion. Force is in linear motion and the same quantity in rotational motion is torque. Okay. Then another difference, that is the second difference is, again in 9th standard when you studied the first lesson, we have never described the mass of an object. We have done many problems, we have done many graphs, but nowhere we have told a body of mass kg is undergoing uniform motion. No, the body is undergoing uniform motion. We have never discussed about the mass of the object. Whereas in kinetics, we say a body of mass 10 kg is moving under a force of 5 Newton. Here force has significance, mass of the object has significance. Hope it's clear for you. So the fundamental differences between kinematics and kinetics is force and mass have no significance in kinematics, whereas we take care of the two quantities, force and mass of the object, in kinetics. Here you have a very simple example to distinguish between kinetics and kinematics. You just observe the two figures. By first look, you may find it the same picture. Of course, it's the same person walking along a straight line. Okay. Now, if you keenly observe, you find that in the first figure, the force exerted by the leg of the man is expressed. Its direction is shown. So, in the first figure, the action and reaction, the forces are mentioned. So, this is kinetics. In the second figure, you see the forces are not mentioned anywhere. Only the angle by which the bending of the knee of that person while walking is expressed. Force has no significance in this particular figure. So, this is an example of kinematics. Now, to study the mechanics, that is kinematics and kinetics, we should know two terms, state of rest and state of motion of the body. Okay, first we will explain what is rest. We have studied in 9th standard, but still I will explain. Now we are all under lockdown, we are all sitting at home, we are not using our vehicles. Okay, your car is parked in the parking area at home. Early morning you get up, You go to the parking area and see whether your car is there. Okay. After breakfast, again you go and check it is at the same position. Again after lunch at 1 o'clock, again you check it is still in the same position. Okay. The whole day at different timings, you check the position of the car. You will find that the car is in the same parking slot without any change in its position. So, this stage where the position of the object does not change with respect to its surroundings with time, that is known as state of rest. So, the car is in a state of rest. Now, state of motion. Okay, on a normal school day, 4:30 school gets over. You are walking and going to the bus shelter. You are standing there waiting for your bus. You can see many vehicles moving up and down on the road. Okay. So, these vehicles are changing their position with respect to the surrounding along with time. When you stand there in the waiting shelter, your surrounding is that bus stop. So, with respect to that bus stop, the position of all those vehicles are changing. Okay. So, when an object changes its position with respect to the surrounding, with time, it is said to be in a state of motion. Another example, you are coming to school with your father in your car. Okay. Your father is sitting and driving. You are sitting in the next seat. So, you are in a state of rest with respect to the car, with respect to the driver, that is your father. Okay. But you have started from your home with respect to your home or a person, your mother who is sitting at home, with respect to her, you are in a state of motion. So we can say that rest and motion are relative. That is, there is no absolute rest and there is no absolute motion. With respect to the surrounding, a body can be in a state of rest or in a state of motion. Hope it's clear. So with respect to the driver in a bus, you are in a state of rest. But with respect to a person standing on the road, you are in a state of motion. Another example is, we all survive on earth. You are sitting in the classroom. With respect to the classroom, with respect to earth, you are in a state of rest. But if someone goes to moon and observe from there, you will be in a state of motion. So motion and rest are related with respect to the surroundings. A body can be in a state of rest, and with respect to another surrounding, the same body can be in a state of motion. Hope it's clear for you. Now, here I have written the difference between state of rest and state of motion. You can just go through this. Now, which are the different types of motion? Again, I think you have studied this in class 6 science. Different types of motion. So, random motion, where the particles move without any rules and regulations. A mosquito flying in air, it doesn't have any regular path, in a zigzag path it moves. So, that is random motion. Then, translational motion, where an object can move either along a straight line or it can move along a curvilinear path. We will be discussing about this translational motion in detail. Then circular motion, where the object moves along the circumference of a circle. Rotational motion, where an object rotates about a fixed axis. And oscillatory motion, the to and fro motion of an object. Out of this, in class 11, we will be discussing about the translational motion in detail. So, how do you define translatory motion? translatory motion or translational motion, both are same. Okay, the motion in which all points of a moving body move uniformly in the same line or direction is called translatory motion. Now, translatory motion is grouped into two: rectilinear motion and curvilinear motion. Rectilinear motion, as the picture shows, the object moves along a straight line, and curvilinear motion, as the name says, it moves along a curved path. Okay, both of them come under translatory motion. Okay, now here I had given you an example for both rectilinear and curvilinear motion. This is somebody started moving from the point A along a straight line and reaches B. Okay, so the object is moving along a straight line, which is rectilinear. Here you can see the object is moving along a curvilinear path. The object has started from the origin, moving along this trajectory, and the position is changing A, B, C. So this is curvilinear path. Both come under translatory motion. Now let's see the flow chart. Types of translation motion is divided into two: curvilinear and rectilinear. Rectilinear, example, a man is walking along a straight line. Rectilinear means straight line motion, and this is one-dimensional motion. Can be along x-axis, can be along y-axis, but it cannot be in xy plane. Whereas curvilinear motion, parabolic motion, the example which we have seen just now, it is along a curved path. It can be in two-dimensional or three-dimensional. Okay, there is no rotation. So children, we have to study in detail about this rectilinear motion and curvilinear motion in class 11. Our third and fourth lessons are motion along a straight line and motion in a plane. So for today, I am winding up. Hope you all understood the different branches of physics and classical physics and its branches, mechanics, and we have to study kinetics and kinematics in detail in class 11, especially about, we will be starting with kinematics and rectilinear motion in one dimension. Okay, so in the next class, we will do rectilinear motion. Thank you.